Hello there, I'm Thomas Hatsios, German America pilot flying the Boeing 787-900 to night flight with Granby overflying Zurich, Switzerland, Germany. They're coming back to the Zurich International Airport, runway 14 for an ILS localizer landing. So I'm in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 in Microsoft Flight Simulator X. I'm gonna start showing the cockpit instruments, the displays, and the functions of the Boeing 787-900Z aircraft. I'm gonna start with the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot flight vector system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot and flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb of the aircraft in tens, hundreds, and thousands of feet per minute, the steepness of the barometric angles in degrees can climb the sun, the radio altitude above the ground level, the altitude indicator with the pitch ladder in degrees and the bank angle in degrees. We have also the ILS localizer, the threshold antennas that transmit the radio frequency from the runways we use for takeoff and for landing. Is received from the onboard antennas of the aircraft, and we can display the horizontal localizer that we use to align with the horizontal component of the runway, and also the angle of approach we use for alignment and for approach with the runway we use for takeoff or landing. So we have also the ILS localizer crossbars. We have the ILS localizer, the instrument landing system. We use a unique radio frequency each time we take off or land in a different airport and runway. Also runway magnetic northbound heading, we have to align with the runway heading for this instrument, the ILS approach. So you're gonna see also that we have the flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode annunciator with the autopilot and the auto throttle, later on vertical navigation modes. We have also the edge side, the horizontal situation indicator that displays the magnetic heading and track, also the flight plan. We can create a flight plan using the flight management computer over here. We'll input all the data of the aircraft just before going to flight. After, I'm gonna show you how to start, make an engine start demonstration. Also show you the flight controls, the engines indications, the navigation display, the autopilot flight director system panel, the overhead panel of the Boeing 787 with all the systems, the whole cockpit. And now we're gonna make a complete flight from takeoff, climb, cruise, descent, approach, and landing with this beautiful jet aircraft, the most advanced jet aircraft in the world. So you're gonna see the Boeing 787. So you're gonna see also, so we're gonna have the navigation display, the HSI, the flight management computer over here. So you can see the flight management computer, what it displays. You're gonna see how we'll input using the keyboard and the display. I will create a flight plan later. I will use also the mouse pad of the aircraft. You will see also we have the mouse pad I have here, the keyboard I use on the screen of the computer, also the side stick that I have to control the flight controls of the Boeing 787. So you're gonna see all the data before we go into flight. We're gonna make a complete manual flight. You're gonna see also the instruments. I will show you now the flight controls. We have also the navigation display. The navigation display that displays the terrain weather reflections from the weather radar. You can see the terrain around the aircraft in a horizontal and vertical profile depending on the distance of the terrain around or below the aircraft or in front of us. We have also the terrain. We have the radio altitude that is displayed also in the vertical display. We have the red, green, yellow, and red, green, yellow, and other indication of the terrain. We have the blue for lakes, rivers, and sea, and also for in the terrain map you can see the airports where they allocated our own airport, the runways and the taxiways we're gonna use for takeoff, following the 4-letter account name of the airport. We have also other airports. We have the navigation aids, the nav aids. That include the VOR stations, ADS and DBs, and the waypoints which are horizontal and vertical navigation fixes and altitude and airspeed constraints. We're gonna have to fly through some waypoints as we're gonna select the flight plan. We're gonna create the one waypoint by another, connect them with a line, a purple magenta line, and it's gonna be flown also by the autopilot and flight director system panel. We'll connect to the autopilot mode. It's gonna follow the flight plan we create using the flight management computer. So we have also the terrain, we have the waypoints. You can see also other aircraft that fly around our own aircraft using the transponder, the DSP and ADC transmitter receiver. The transmitters are radio frequency to other aircraft and the air traffic control received from other aircraft. You can calculate with this computer the other aircraft distance from our aircraft up to 40 nautical miles or 72 kilometers in a 360 degrees radial around the aircraft. Also, you can calculate the other aircraft distance, bearing altitude difference from our aircraft in hundreds and thousands of feet above or below the aircraft. You can also calculate, it will show us the diamond shape of the other aircraft with the altitude difference displayed next to it without plus or minus sign, and also an arrow up or an arrow down indicating the other aircraft is either climbing with respect to other aircraft or descending with respect to our aircraft. You can also calculate the velocity closing between our aircraft and the other aircraft. It will give us a warning from the TCAS system, the traffic collision advisory system. When we have an incoming collision in the air, we make an avoidance maneuver. So you will see how we use the TCAS system of the aircraft. So you can see also the outside view, also the flight controls of the aircraft, the view. So we have a few more minutes for that. So we're gonna make a little bit faster this time. You can see also another aircraft that is coming up. So I'm gonna show you the flight controls of the Boeing 787. Also the computer, I use the keyboard, the side stick, the mouse pad over here. I need for the autopilot settings and other settings like the flight management computer. So you will see here I have the side stick, the Lszh Extreme 3D is identical to the Airbus, so we can climb, we can descend, pull, move back and forth the side stick or the control column of the yoke. We can either climb or descend the aircraft. We can make also left and right side stick is the yoke control wheel, left and right turns in the air using the ailerons and the spoilers. So back and forth is the elevator, the horizontal tail of the aircraft, climb, descend. And you can see also we have an incoming another aircraft, a Boeing 737-800 with the spoiler over here. So we have a Boeing 737-800 coming for landing. As you can see, just touchdown here. It goes in the runway. So you can see the flight controls. Also we have the stabilizer trim over here. The switch, we have the rudder pedals, left and right input for controlling the vertical stabilizer, the tail of the aircraft. Left and right turns in the air. Also in the ground we have the tail, the rudder, and also the nose wheel steering, left and right turns like this using the rudder pedals. Also we have the brakes, that's all we have. Also the stabilizer trim switch over here. Trim up the elevator or trim down the elevator as we fly. The autopilot disengage, the head up declutter over here. You can see also the primary flight display, navigation display, ACAS, engine indication, controller system display. So we can see here we have the elevator trim, very important when flying an aircraft. We have to trim the elevator, the horizontal tail, or the whole stabilizer, the whole tail, depending on the aircraft. So we can use the trim switch up to trim the elevator up like this, or trim the elevator down like this. So we pitch the nose up as we fly, or we pitch the nose down as we fly of the aircraft. As you can see, also we have the yoke here, the control wheel, the steering, and the control column, so we can climb and descend like this. Also make turns to the right, to the left. You can see elevator trim, left click down, right click, should be read by the tag over here. Yeah, elevator trim, left click down, right click up. So this way you trim the elevator up, you pitch the nose of the aircraft up as you fly, and this way you trim the elevator down, you pitch the nose of the aircraft down as you fly. So you have this aerodynamic effect. In flight you have the flap speed over here. I'm gonna show you as much as we have time. Also you have the alternate trim switch over here in case you have a failure like the Embraer aircraft, and the CRJ aircraft. The Airbus aircraft have the trim wheel here. Also the Boeing 737 has a trim wheel. This newer model Boeing 757, Boeing 767, Boeing 777, 747 have only trim switches. They have no trim wheel. Also the Boeing 787 is fly-by-wire, like the Boeing 777. So you climb the sun. You can see the elevator trim. This way you trim the elevator up, this way you trim the elevator down, so you pitch the nose up as you fly and you pitch the nose down as you fly. Also you have the stabilizer cut-off switch over here. You can cut off the auto trim function of the Boeing aircraft if you have some failure, and use only the manual trim, very important. So this way you trim the elevator up, you pitch the nose up, you trim the elevator down. You have also the parking brakes over here. As you can see, the fuel control, left and right engine, the thrust levers, the flaps over here, flaps lever. So you can move, extend or retract the flaps position like this, up and down, extend or retract, very important for flying the aircraft. Have the correct flap settings. Also speed brakes are retracted, extended. So you can see the computer, very nice, very beautiful. We need for our flight plan for the navigation of the aircraft over here. So you can see also we have a couple more switches over here. We have the control, the fire extinguishers, left and right engine, the transporter, the radar trim. We have the navigation radios, satellite, cabin, ground proximity, weather, transporter, VHF, frequencies for the air traffic control and the tower. We can switch the normal or the alternate. We have a backup frequency. So you'll see all these things. Also the autopilot flight director system panel over here, and the FS panel, the displays. So we have the autopilot here, and gates and descent gates switch, as you can see. The LNAV and the VNAV, I'm gonna set them later. The airspeed guidance 200 knots, will increase the airspeed later or decrease if we need. The flight director, auto throttle left and right, the heading in magnetic North Pole heading, the altitude select and the vertical rate of climb descent, how fast the aircraft climbs and descends in thousands of feet per minute or angles of degrees. So we have the stabilizer trim that I show you here. So we pitch the aircraft the nose up or nose down, elevator up, trim elevator up or trim elevator down. We can see we have the flight control computers here in the overhead panel. In the normal mode, this is a fly-by-wire aircraft. You can see primary flight control computers in the auto position or disconnect. It's like the Airbus aircraft. Also the hydraulics. So I will explain you what I mean. Like in the Airbus aircraft, you have the flight control computers. When you fly, you input using the side stick, you give a command to the flight control computers to control the flight controls deflection in order to make the aircraft stable in flight with 1G level flight, where 1G is the acceleration of the air gravity. When making turns left and right, you have 2.8G in left and right turn, maximum turn with the flight control computers. In the normal mode, we have the normal, the alternate and the direct mode, and the mechanical backup for the flight control computers. So 2.8G or 67 degrees of side stick deflection, making left and right turns. Also when we climb in the Airbus, we have 30 degrees or 1.5 G of positive G climb, and also when we descend we have minus 15 degrees or minus half G of descent rate. So in the Boeing we have similar controls. Also both the Boeing and the Airbus has the auto trim function. You can trim the horizontal tail when it's flying automatically without our own input. We don't need to do nothing, just move the yoke of the Boeing or the side stick of the Airbus. So you can see here we have the auto trim function. We can move also, we have the manual trim in the Boeing aircraft, the manual trim switch, or in the Airbus we have the trim wheel. We can input the trim wheel if we need. So I will show you here what I mean. You can see in the Airbus we have climb 30 degrees or 1.5 G descend minus 15 degrees, so minus half G, and making left and right turns 67 degrees at maximum side stick deflection on 2.8 G. Also, if we release the side stick, the aircraft goes back to 33 degrees. We have to turn it around to go back to level. We have other limits, and like the alpha floor, the alpha protection system in the Airbus. If we have a 1G stall angle of attack in the air and the velocity low is for stalling the aircraft, we have the takeoff ground lock, and the angle of attack of the Airbus is going to be limited until we exit the stall condition. So this is the alpha protection, the alpha floor of the Airbus. We have also overspeed, minimum speed protections, other flight maneuvers. So we have similar modes in the Boeing aircraft like this. You can see the flight control computers. If you have a failure over here of the Boeing aircraft in the hydraulic system that control the elevator of the aircraft, you can see here is the elevator, the horizontal elevator. We need for climb, descend the aircraft like this. Pull the side stick up, we climb, pull the side stick down, we descend. Also the rudder. So if you have a failure of the controls, the elevator trim, hydraulic actuators, you can see the hydraulic pumps, left and right engine driving, electric C1 and C2. The flight control computers over here are gonna be degraded from normal to alternate or direct mode or mechanical backup, so we're gonna lose the automatic trim. The autopilot will be disengaged automatically. We won't be able to use it, and we have to come down here. We'll have to fly manually the aircraft. This is for all Boeing 737 over here, Boeing 747, Boeing 757, Boeing 767, Boeing 737, Boeing 777, Boeing 787. You open this red guarded switch you see here from normal to cutoff, either left or right, either one or both. This is for the left tail and the right tail, horizontal tail of the aircraft, from normal to cutoff, and then you use only you lose the auto trim, the automatic trim, use the autopilot, fly manually, and use the manual trim switch here and here for trimming the aircraft. You can use the manual trim switch anytime in the air. It's very nice when flying manually. So we trim the elevator up or trim the elevator down like this, pitch the nose up or pitch the nose down. So you can see how many degrees. Also you can see the manual trim switch here. So you can see how many degrees we trim the elevator when flying. Elevator stabilizer trim right now is 5.25. We trim it a little bit higher than it should be. Nose up, nose down. Rudder trim, 0 position. Flaps position. We have some indications here. So maybe we cannot trim down a little bit. The tail we need to be at 4.25 degrees, a bit lower. So it's gonna be 5 degrees. It's gonna be a little bit lower. Like 4.25. So we have nose up, nose down, the flaps position, landing gear over here in the ACAS and the indication controller system display, landing gear extend and retract, alternate gear over here, lock override, alternate gear, auto brakes, exit takeoff. The displays, you can see the left and the right engine indication over here, displayed by the FADEX, by the full authorities electronic control computers. We have the left and the right engine indications. So we have the N1, I will explain you later. You can see the stabilizer trim, the rudder trim, the cabin pressurization here, the outflow valve. So when we climb the aircraft like 45,000 feet, the cabin pressurization inside the cabin should be 6,000 or 7,000 or 8,000 feet, and the differential pressure 7.8 or 8 psi. So we have also gross weight for takeoff, total fuel on board, fuel minimum temperature, the outflow valves position, open and close to pressurize or depressurize the aircraft cabin. You can see also the engines here. The N1, which is a low speed starters, have low pressure compressor turbine of the turbofan engine, exhaust gas temperature per engine. N2, which is a high speed starters, have high pressure compressor turbine of the turbofan engine. fuel flow parameters per 1,000 kilograms per pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. The cabin pressurization also is supplied with pressurized air from the engines in some aircraft, or from the APU, or from outside source. So from the packs over here in the overhead panel, you can see the packs control. You can see also the outflow valve for the cabin pressurization, normal, alternate, air conditioning. Also we have wing and engine RDIs, hydraulic fluid tanks, pressurization from pressurizer, air conditioning, and oxygen. So many systems are supplied from the engine's pressurizer in a normal jet aircraft. So we're gonna see a few more systems before going into flight. So I was talking to you also about the flight controls of the aircraft of the Boeing 787. The side stick, how we control the flight controls. I will show you now the outside view, and I will talk to you about Newton's physics, aeronautical and aerospace engineering, Newton's physics, burning theory of fluids, and some principles we need to know, aerodynamics and flight dynamics for the air traffic, for the air transport pilot license and the commercial pilot license, the ATPL theory and the CPL theory. So here we have another aircraft coming for landing, as you can see. Another Boeing 737 just spotted. So this is we need to know for the air transfer pilot license and the commercial pilot license, the ATPL theory and the CPL theory. We need to know aerodynamics, flight dynamics, and other aircraft systems. And so also in the outside view, you will see also how you saw the size without the flight control. So we have the surface area of the forward wings, called the weight of the aircraft when the aircraft is flying. The weight of the aircraft is divided over the surface area of the wings, because the lift that acts over the weight of the aircraft, it acts here, is the center of lift usually in the forward wings, the center of pressure. So we have also the mean aerodynamic chord position here. I will talk to you about now. So we have the lift overcomes the weight down from the earth, and also the aerodynamic flow, the airflow from around the wings below. We have higher pressure because the airflow is moving slower below the wings, which pressurize the aircraft weight and wings up into the air. Also the airflow is moving much faster above the wings, which creates a lower pressure, which sucks the aircraft wings up into the air and the weight. So we have the thrust, these vectors from the engines, the jet plus, because it's the jet aircraft. So we have the high pressure compressor and turbine over here, the high speed starter and shaft, and the low pressure compressor and turbine, and the low pressure starter and shaft, and the front fan. This is jet turbo fan with the engine. So we have the fans here, and we have the bypasser from the fan. And we have the high pressure with the combustion chamber, the exhaust that moves out the jet blast of the jet engine. So we have two engines for stability in the left and the right wings symmetrically. So we have the fuel flow is coming down from the wings, the fuel lines into the engine combustion chamber from the left and the right wing fuel tanks. So we have the left wing tank here, the right wing tank here. We have the fuel booster pumps over here, and the fuel lines. Also we have the center tank over here, and we have the wing and engine RDIs lines over here, with hot air from the engines coming back from the engines from the manifold over here area to heat up the wings for RDIs and the engines. So we have this is the engines explanation. We have the thrust reverse also. So we have the mean aerodynamic chord where the maximum aerodynamic lift occurs, 33% for this aircraft and this flight of the mean aerodynamic chord position, where the maximum aerodynamic lift occurs where the center of pressure is moving back and forth. Also the stall, the airflow becomes detached from the top surface of the wings, and the wings are stalled for a given angle of attack and airspeed. So you need to monitor here in the primary flight display when we fly. You will see the stall speed will be indicated with a red and yellow indication below the airspeed when we fly. So we need to avoid the stall. We push the side stick of the yoke down, and we apply as much thrust as we need to exit the stall condition. So thrust with the engines as forward, as you can see. So you can see also the aerodynamic core that we have the center of gravity here, where is the yawing axis of the aircraft. So the yawing axis, you use the rudder to yaw either left or right, like this. I have it in my side stick, left and right rudder turns. You can see the rudder pedals we use inside the airplane to make left and right turns of the aircraft in the air. It's very safe and very easy to use. You can see also for turning also we have in the ground the nozzle together with the rudder. It's automatically interconnected from the computers. When we move the rudder pedals, we don't need to move the tiller all the time. We just need to move the rudder pedals also in takeoff and in landing. So from 0 knots up to 45 knots or 72 kilometers an hour. The forward nozzle is deflected either left and right direction up to 76 degrees from the computer automatically. At 45 knots or 72 kilometers an hour, the rudder becomes more aerodynamically effective. So the computer will limit the forward nozzle deflection from 76 down to 7.6 degrees either left and right, like in takeoff or in landing. So in takeoff up to 80 nautical miles per hour or 144 kilometers an hour, you have the rudder aerodynamically effective. Then above 80 knots or 80 nautical miles per hour, 144 kilometers an hour, the forward nozzle is gonna be locked from the computer at 0 deflection or like 1.5, 0 or 0.5 or 1 degree left and right deflection. So you have only the rudder for controlling the aircraft after that. From takeoff to complete the flight, then at the landing. After touchdown, first you have the rudder, then as you slowing down the aircraft in the runway, the computers will let the forward nose will come in for directional control. So this is the theory of the rudder pedals. We have a couple more things, controls over here. So we have from wingtip to wingtip, we have the elevator is the pitch axis, the side stick back and forth. In the Airbus aircraft, you can see the elevator, left elevator, right elevator. In the Boeing also the same, no difference. In the Airbus you have the side stick to take the weight up and climb and take the weight down and descend. In the Boeing you have the control column of the yoke, as you can see over here. So it's the same, no difference. You pull the yoke up and you climb, you pull the yoke down and you descend. Same like the Airbus, when you fly you have no difference in the feeling of the flight controls. Personally for me, I see no difference. So climb and descend with the Airbus. With the Boeing, no difference. Also both sides in the Boeing are interconnected. The captain and first officer move together the same. So we'll explain also that. So climb and descend. We have one more axis, the longitudinal axis from nose to tail. In the Airbus we make ailerons and spoilers left and right wing. You can see ailerons and spoilers extended. So we use ailerons and spoilers to make either left and right turn by making differential pressure. So this is left turn, this is right turn, differential lift. So you roll left and right, very easy, very safe to use because you can climb the same time or descend. There is no problem using all flight controls together, have coordinated flights. So ailerons and spoilers, you see ailerons here, spoilers here, also the flaperons of the Boeing, one more flight control. Also the speed brakes fully extended, left and right wing, and the flaps with the slats fully extended to here. So this is the flight controls explanation. In the Boeing you have the control wheel to make left and right turns, ailerons, spoilers, left and right turns. In the Airbus you have the side stick left and right, same thing, no difference for me. You can see the side stick when it's deflected, it's the same like the Boeing, the yoke, the control wheel of the yoke. So we have one more thing to see from the flight controls. I will show you now the rest of the systems make up the flight management computer and the autopilot. and make the engine start demonstration. So we have a few more minutes for that. So you will see now the side stick from another view. Very nice view. I hope you're gonna like it. So you can see here the side stick we can climb, and we have a nice view here. So you climb and you get ascend with the Airbus or the Boeing, no difference. You have the side stick in the Airbus, as you can see, because this is identical to the Airbus side stick. So you climb and you descend, you make turns to the left or to the right, no problem with that. So you make right and left turns, and you climb and you descend like this. So climb, descend, make turns to the right, make turns to the left. Very easy. Climb, descend, make turns to the right, make turns to the left. Also you have the thrust control, thrust levers over here, actuate the thrust. Very easy. You see how many degrees. You move the thrust levers forward, full takeoff, or back to the idle thrust reverse, also horizontal. Trim stabilizer over here. So hope you like my side stick. Let's take extreme 3D over here, and the controls. So you see we have the side stick priority button like in the Airbus aircraft, the autopilot disengage, and the push to talk button. So you can see also the outside view. Again, one more time, the flight controls. Controlling the aircraft around the flight control axis. Climb, descend, rudder, left and right rudder, ailerons and spoilers. Very easy. So hope you like my side stick, my computer. So this is the flight controls lessons for tonight. As you can see, both side stick are moved together in the Boeing, are interconnected. Also the rudder pedals in the Airbus are interconnected. In the Boeing you have to use some force in either side to override. In the Airbus you just need the side stick priority button. Rudder pedals are interconnected in all aircraft, airliners aircraft, both sides, Airbus, Boeing, Embraer, CRJ. So we have the side stick priority or dual input. So I will show you now the flight management computer very quickly inside the aircraft, and a couple more controls and screens, and we go for full flight. So we need to set up the flight management computer over here. So the flight management computer will input all the data we need for this flight. Also it's going to be flown with the autopilot flight directory system panel. If we connect the autopilot, it's going to follow the flight management computer, the flight plan I'm gonna create right now. So you will see how I'm gonna use using the mouse pad here that I have on the keyboard. I will make a flight plan for this aircraft using the takeoff, gross weight, other data, the center of gravity of the aircraft. So you can see here the screens. We can control what we need for that. So we have the index over here. You see identity, Boeing 787 aircraft, model index, position, performance, takeoff, approach, annunciate status, navigation data, flight plan, loaded traffic control plan. So we go in this view for that. Control quadrant. So you can see You can see the flight management computer, the mousepad that I have here, also thing with the data. So we have the screen, the keyboard, identity, Boeing 787, GNX engines, Boeing 787-900 position, Lszh airport. We can align the IRS inertial reference system like that with the longitude and latitude coordinates and the magnetic north pole, geographic north pole. Performance, gross weight, zero fuel weight plus fuel on board, gross weight for takeoff, reserve fuel, cruising altitude, cost index, fuel freezing temperature in flight is gonna freeze, cruising center of gravity. So we set up the route first from this airport, Lszh, Zurich International Airport, back to Zurich International Airport, Lszh. Copy paste, clear. Use runway over here, 14, runway 14, the route, departure over here, as you can see, departure and arrival. So we set runway either 10, 14, 16, to it we can select either runway 14, 10, 16, so select runway 14. The seeds are the southern instrument departure waypoints and fixes, the seeds. For the initial departure flight, we have arrival. We can select runway 16, runway 28, runway 34, runway 14. So we select ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we select ILS 14, trans Mickey over here, and trans the stars is the terminal arrival, waypoints and fixes. We have the Negria 1 Alpha. So we have the legs are created, the route. You can see the first waypoint after takeoff. We're gonna follow also with the autopilot we need. Zurich climb to the cruise level. Negria motive descent here, approach and landing, Zurich 701. So we need to activate zero fuel weight plus fuel on board, gross weight for takeoff, reserve 5%, cruising altitude 35,300 feet over here. And the cost index 100%. We execute, it's gonna activate the route, as you can see. So we have activated the route. This is the first waypoint after takeoff, 2 nautical miles from the runway, 250 knots, 1900, 1356 nautical miles away. Make a left turn, Zurich 301 knots, 6000 above the sea level. Climb to the Negria 071, heading 26 nautical miles, 301 knots, flight level 22,200. Make a right turn. 12 nautical miles is the motive, 320 knots, 11,800. Descent 6 nautical miles. Hammock is Zurich 9 nautical miles. Zurich 701, 6 nautical miles from Zurich, 180 knots, 6,000 above the sea level. Here's the approach, TRA. 10 nautical miles, C114, 6 nautical miles, make a left turn for alignment with the runway, also the ILS localizer, 5 nautical miles, 174,000, runway 14, also take off, go on, flaps 15 degrees, center of gravity trim 33%, 4.35, takeoff speed V1, we rotate V2, gross weight and runway position. So we have departure, arrival, alternate, VNAV, progress, FMC communication, progress, hold over a waypoint, we can hold and fix. Also use navigation radio, tune ILS localizer, for ADF over here. So go back in the virtual cockpit to complete the pre-flight data we need. So we're gonna see now we have created a flight plan. It's gonna be displayed over here from the legs. As I told you, over here you can see the legs display. Also here in the HSI, you can see one waypoint by another, the name of the waypoint, of the fix, of the waypoint fix, ADF, left and right. Also here you can see the Düsseldorf airport, 16 nautical miles away, the terrain, red, green, yellow. Over here the elevation of the terrain, the distance, 40 nautical miles, 80 nautical miles. The flight plan, the vertical, as we're gonna be flying. So we look a little bit closer. You will see the terrain. You can see the flight plan better over here. The purple color, the terrain, the elevation of the ground below us, green and yellow. We're gonna have in the terrain below the aircraft when we fly. If we look up closer, you can see the runways here. The runway we're gonna use for takeoff, the taxiway, the other runway of the airport. You can see the terrain again as we're gonna be flying. So this is the taxiway we are over right now, and the runway we're gonna use for takeoff and for landing as displayed from the GPS here. You can see our location is very precise. Also the terrain around, away from us, you can see the mountains. So we have a couple more minutes. You can see also this display, terrain over here, center display. Further away, you can see also this view of the plane closer or further away. We're gonna see later in flight. Map setting over here. So we have the runway, we have the flight plan, we created other airports. So we can see here is the primary flight display, very important. The airspeed indicated, the airspeed selected from the autopilot flight director system panel, the barometric altitude above the sea level, the radio altitude above the ground level, the barometric pressure of the outside atmosphere. We set the barometric altitude with the barometric pressure here. So we set this is the baro set inches of mercury, hectopascals, radio baro, weather radar, plan, rains, traffic on the display, system, CDU, info checklist. So we have the pitch ladder in degrees. You can see 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 2 degrees for pitch up and pitch down. Bank roll like 10, 20, 30, 45 degrees, left and right turns. Also when we climb and we descend, you see this needle moving up when we climb, 500, 1000, 1500, 2000, 3000, 6000, climb or descend. So we have all the air data. We're gonna start the engines right now very quickly. Start the APU. Also we have the left and right IDG, the great drive generator, left and right engines, the battery, primary flight control computers in the auto position. So 100 to 200 volts for 100 Hz frequency, 138,000 kilovolts. Air data computer, flight control surfaces, FD door over here, battery, FD door, towing power, passenger oxygen over here, window heat, ram air turbine, backup hydraulic, left and right engine driving, and primary demand, electric C1 and C2. So we have the off, back to the on position. I'm gonna make an engine start demonstration. We can engine on the ice over here, normal and auto and manual cabin pressurization, climb and descend, use the alpha valves to pressurize or depressurize the aircraft. In the auto we need to do nothing, air conditioning, ventilation, and oxygen, cargo fire, recorders, electronic engine control for the engine with the auto start. You can start the engine. We have the normal and the alternate mode of the engine control. Fuel jettison, we can dump some fuel inside. We arm the switch, select the nozzles and how much to remain. Also left and right wing fuel booster pumps over here. Center crossfeed, we can use the crossfeed valve to feed either engine with other pump or either tank, or balance the fuel between the left and the right wing. So we have the wing and engine the ice in the on or auto position. So this is the systems we need to know right now for making the engine start. The APU, the auxiliary power unit, is going to give us pressurizer and electric power. We need also a little bit lighting. So I believe we left over some minutes over here. So we have the checklist, the systems. You can see systems display, the hydraulics, left and right APUs running, oxygen, liquid cooling, the electrics, left and right IDG, 180 to 200 volts, 400 Hz frequency. Also the oxygen here, liquid cooling, as you can see, oxygen quality. The electrics, the APUs running, the battery voltage, charge and discharge, the generator drives, and the volts, barrels, load cell. So we have a couple more things to see. Hydraulics, Where the hydraulic fluid goes, which system use hydraulic primary demand, left and right engine drive, electric C1 and C2, 5100 pressure, shut-off valves, isolation valves, the fuel, left and right wing, fuel tank, center tank, low and high pressure fuel valves, left and right engine. So we have 11,000 total, 34,000 pounds. We can see the minimum fuel temperature down here, below which the fuel will freeze in flight. So we need the FADEX, level authorities, electronic control computers to control the engine, also control the transfer of fuel from the left and the right wing and the center tank into the engine components to heat up the fuel. Then they transfer the fuel back to the tanks. So this is the fuel transfer. You can see minimum fuel temperature minus 37 degrees and the fuel temperature now minus 6, as you can see. So this is automatic. Also the lubricant and the oil, the crossfit valve will be turned on to feed either engine without pressurized tank. The use for left when uses this motor, the air pressurizer for oxygen, cabin pressurization, weaken engine at the eyes, hydraulic fluids. The doors are closed, the cabin can be pressurized over here. The gear, pressure of the tires and temperature of the brakes, flight controls over here very quickly. So we move the flight controls, climb, descend, make turns, right, left, rudder, pedal also. So you can see the deflection here of the flight controls, and the tail, horizontal tail and vertical tail, and also the trim position, FS display, maintenance over here, maintenance, systems, menu, circuit breakers, back, and then we have the checklist, last thing to do before takeoff. So we have the checklist, normal menu, before, start, after takeoff, descent, approach, landing, navigation display, also communication. So we need to make an engine start demonstration. Here we'll turn off both engines and restart them. So fuel control in the off position, as you can see. You will see the messages here coming up. Have the engines off, fuel pumps off, fuel starvation, and the engines are slowing down. So we'll look outside. You can see the Boeing 787 over here. Both engines are off. So we need to come up here in the overhead panel and restart both engines in the automatic mode, in the auto start, as you will see. So we have the reconfiguration, yellow indications, yellow amber color for the auto start position, because now we have pressurizer from the APU is coming into the engine, and 2 stages, only pressurizer, no fuel yet, as you can see. So we have only pressurizer right now. So above 20% we can let the fuel control on, fuel flow on, both left and right, fuel transfer. So we have the auto start. Now we have both pressurizer and fuel into the engines, the auto start. You can read the auto start. You can see also above 47, above 50, the message is going off. We have running engines at 62%. You can see both engines running automatic. So we use flaps up like this, 2, 3, 5, 6, speed brakes arm, and we set the autopilot before flight. You will see now the autopilot of the aircraft. So we have auto throttle left and right, the airspeed we can set whatever value we need. We set for takeoff. So here is auto throttle left and right, or flight director. The LNAV and the VNAV from the flight management computer, you will follow the flight plan. So we turn off the flight director, we will disarm the modes, we need to rearm them. Autopilot disengage like this, bank angle, limit, and heading, we're gonna select the heading 136 degrees like this. Vertical speed we're gonna climb, we can descend, you will see zeros, level of descent, minus like this, and also climb. We're gonna use the other side, how fast the aircraft will gonna climb or descend. Also the altitude, thousands and hundreds of feet. So now we go for the takeoff. We take the clearance from the air traffic control and taxi to the runway. As you can see, advance the thrust levers forward. Idle thrust. So we need to taxi into the runway like this, as you can see. There is no other aircraft coming in. So we align now with the runway center line like this with the tiller and the rudder pedals. So we're ready. We're now for takeoff. Thank you very much for listening to me until now. I'm Thomas Hatsios, I'm America pilot flying the Boeing 787-900 jet aircraft. So stay with me. I'm gonna fly now manually and using some autopilot the Boeing 787. I'm starting now the takeoff process. So thank you again for watching me. So we start now. You can see the side stick controls, the thrust levers. We advance the thrust levers forward. Also here, parking brakes off. So we are in the runway 14. We press the side stick down until 80 knots or the yoke. So we align now with the runway center line using a little bit of rudder pedal. So we have 130 V1. We rotate 9 degrees, pitch 9 degrees like this smoothly for rotation for takeoff. So we won't strike the tail on the runway. We need to pitch the aircraft only 9 degrees or less. This aircraft actually, other aircraft have different limit, slightly different. So we climb. You can see we can leave the hands off, no problem, from the side stick or the yoke. It keeps climbing. Only an airplane can do that. So we can push down a little bit, body gear up, positive rate of climb. You can see all the indications of the data we have. So you can see the airspeed 200 knots. We are 2,000 feet above the ground. Keep climbing. 2,400 above the ground, about 4,000 above the sea. You can see the airspeed, the wind direction, the stall speed. We climb with 4,000 feet per minute right now, 5,000 feet per minute. You can see the trend line. Also the runway Lszh localizer. Here are the flight plan, the terrain, red, green, yellow. Terrain indication, the pitch altitude also. If we climb the pitch altitude, we're gonna have the stall speed coming in, so we decrease the pitch altitude. Also you can see the terrain over here, the engines, terrain below the aircraft and around, stall speed here, the marking with the red and yellow. So we have the aircraft is 4,900 feet above the ground right now, 5,100. This is above the ground signal from the radio altitude. Also the terrain, you can see up to 20 nautical miles away from us right now. With green, this green wave below us is the terrain. Also around us you can see the mountains, the valleys, the sea, the lakes, rivers as we climb. So we have some lakes over here, and this is displayed with black over here. So we keep climbing, and we need also to make the turn. You can see the lakes displayed in the map. So this is the departure from the airport. We're gonna start the turn now. So turning now to align with the flight plan, follow the flight plan, and we have about 18 more minutes for this flight to end. So keep climbing. So we need to follow the flight plan, as you can see. So you can see we can leave the hands off from the side stick, no problem, with an airplane. Just need use a little bit right rudder, right turn now. Need to align with the flight plan, as you can see. So this is the night sky of the Switzerland below us. Also the cockpit just after the takeoff. Cockpit view after takeoff. So here's the climb rate. Over here the head-up display, same things like the primary flight display over here. You can see the stall speed now with the red and yellow, the airspeed 170 knots, also the climb rate. We're inside the flight director crossbars. We need to make a small turn to the left to align with the flight director, to follow the flight director lines. So here is the climb departure from the Switzerland, as you can see. Very beautiful view of the aircraft. A little bit night view, night flight this time. I'll be like keep climbing here, make a turn, align with the flight plan also. You can see the flight plan is these purple lines which need to follow here. Keep maximum thrust for now. Also use the rudder pedal, either right or left, to align with the vertical tail, using the vertical tail of the aircraft, the rudder pedals. Whenever it's needed, ailerons, left and right, and spoilers, ailerons and spoilers. So climb, we have the elevator, or a descent, level off also, is the elevator back and forth. Maybe we're gonna connect the autopilot in a couple of minutes. We have to cross through a waypoint over here, that's for display. (19,000 feet). You can see the wind 25 knots, the ground speed of the aircraft and the wind. The waypoint we need to follow now is the Nigria, 23.7 nautical miles away. Over here displayed also in the flight plan as we climb. In the other side of the flight plan also, both sides have the same indications, as you can see. So we need to align a little bit now. So we keep climbing. Over here, as you can see, we have the France over here, the Germany, Swiss, the Switzerland, the lakes. So it's the Bayern Munich, Germany, my homeland over here, and the Switzerland. We need to make the turn now. You can either fly manually or make the autopilot command. So Mati Vamiki, use the Amiki now and press the execute like this. You will see now we're gonna connect the other line. We keep flying manually, very easy. So we start turning here. manually. So you see we turn manually, no problem, like this. Leveling off also. We will use the autopilot for display a little bit later. 32,000 feet. So here we are in the middle of the turn, as you can see. So we keep turning. Hope you like the view of the Boeing 787 as we make this turn over here, overflying Germany, France, Switzerland. As you can see the Bayern Munich here. Can level off. We have also the frozen vapors of the aircraft. See, this is the Boeing 787, and we have so you can see now we align with the line here with the flight line. We can level off actually. Increase pull up the flaps. So this is a beautiful view over here. Hope you like. Night flying this time. Another aircraft coming below. So we need over here connect the autopilot maybe. If we need to use the autopilot, you'll see. Now we have arrivals over here. Select arrival, Lszh 1 France. One more time, France-Negria. Select and execute. So we press and we have the arrival now. Over here in the legs we need to follow. So here we are, we follow the flight line. As you can see, autopilot now is commanded. So we have the most beautiful view here, night sky also. 2 months of night sky, as we have done this earlier. So you can see the autopilot disconnect. I don't know why it's following this waypoint wrong. So we're following manually now, flying manually. As you can see, 35,000. We need to descend in a while, so we autopilot again. Use the LNAV. Also the descent over here, I'm gonna start descending. Vertical speed. Increase the vertical speed here. And decrease the airspeed. So this is following the autopilot mode, as you can see. We need to use the speed brakes and idle thrust over here, as you can see. Autopilot disengages it again. So we use idle and make the turn here. Keep descending like this. So this is a night view of the approach, as you can see, into the airport. Keep descending. So you can see the airspeed max 0.7, the altitude 15,000, 16,000 feet right now. We decrease the airspeed for approach and landing. And we have 6 more minutes to go. We advance the thrust levers a little bit. You see the indications. So here is the descent of the aircraft, the Boeing 787. We're gonna start the turn now as we are descending. We need to align with the flight plan here. So we have 5 more minutes. Keep descending. So here we are aligned with the flight plan, as you can see. We need to decrease also the flight controls a little bit less. Now to get it down. Flaps also extended. We need to decrease the altitude. We left a little bit higher than we should be. Need to align with the runway. So we were a little bit higher. Now we are aligned for approach and landing, as you can see. Also the outside view of the approach and touchdown. Keep coming down for approach and landing. We have some side wing over here, as you can see, some wind gusts. Apply more thrust like this. So align with the runway. We need to flare over here. We need to go around. made a mistake, so we go around. So this is a go around, as you can see. We have a few more minutes to go around. So we follow the blue line over here. We have a couple more minutes. Hopefully we're gonna make it for approach and landing. You can see we're going around like this. Before the video will end. So here's the other runway after the go around. So we have 1 more minute left for landing. The aircraft need to fly faster because the video will end. So this is how the video will end, unless we make something very clean here. So here we are, just landing in the runway, no problem with that.